Alright, so this is LeetCode 70, climbing stairs. So it says you're climbing a staircase, it takes n steps to reach the top. Each time you climb either 1 or 2 steps. The question is, in how many distinct ways can you climb to the top? Okay, so for this example, our n is 2, meaning it takes 2 steps to get to the top, meaning that imagine our staircase was of size 2, right here, and then it's given in the prompt that we could either take 2 steps. So if you've ever climbed steps before, you know, like when you skip a step, you know, you take that big step, or like you put your leg, like you skip a step, you know, you take that bigger step, you stretch a little and take that bigger step, and then you jump up to it. So you could either do that, or you could take one step at a time, right? So you could either go like this and like that, or you could go and just take the 2 steps at once and then be at the end. So there's 2 ways to do this, right? Okay, so that's why in this example we would output 2, because you can think of like our player or character can take either 1 step at a time. So he takes 1 step, so these red arrows is 1 path he can take. Or since he could skip a step where I guess he has like long legs, or he's flexible enough where he can just take 2 steps and then be at the end. So this purple arrow represents 1 path, and then these red arrows represent another path. So that's why we would output 2. Hopefully that makes a little bit more sense as to why we'd output 2. And then for this example, we would output 3. And then let me just draw a picture to explain it, and then we'll get into the actual solution. Yeah, so for this one, you could take 1 step, 1 other step, and then 1 step as well, right? Or, let's do it in blue, you could take 1 step, and then 2 steps, or, what's the final way that you can do it? You can take 2 steps, and then 1 step. So, realistically, we're finding all the combinations of either 1 step, or 2 steps, that bring us to our goal, right? Our n. Okay, so getting into the explanation for this algorithm, it's going to be a dynamic programming algorithm. It's not that intuitive, but I think the more that you see these types of problems, you're going to pick up on the pattern and be able to apply them in different problems. Okay, so we know that for n is equal to 2, there's 2 ways, and for n is equal to 3, there's 3 ways. And also, if n is equal to 1, so let's say that we just had 1 big step, or 1 step from the ground floor, how many different ways is there to get there? There's only 1 way. You can only take 1 step. So we know that when n is less than or equal to 3, then n is just the output that we're going to do is the output we're going to produce is just the size of n, right? So basically what I'm meaning is that, or what I'm saying is that let me get rid of this. When n is less than or equal to 3, the output is just going to be n itself. Output is n, right? What about 4? We don't know anything about 4 because they didn't give us that example here, but let's go ahead and walk through that example. So, from uh, from this place here, how many times can we get, or how many different ways can we get to this same spot? From 4, how many different ways can we get to 4? One way, right? Which is basically we don't move. There's one way of getting there. From here, from 3, how many different ways is there to get to 4? There's just one way, which is you take one step. From 2, how many different ways is there to get to 4? You can either take one step, or you can take a big step, which is basically 2 steps in one, right? So this is 2. And you could try taking one step, 2 steps, but you overshot it, and you're at 5 now, so that's not allowed, that's out of bounds. Okay, from here, how many different ways is there to get from 1, how many different ways is there to get to 4? You can either take one step, or you can take one step, 2 steps, or you could take 2 steps, 1 step. So it looks like there's 3 different ways, right? 3 different combinations. And hopefully you can see a pattern already. What we're doing is we're doing a bottom-up approach. We're starting at our given value, and we're working upwards towards our starting position, right? So these 2 are always going to be set to 1. And then what we're doing is, this is basically like the Fibonacci sequence. What we're doing is we're just adding the 2 previous numbers to get our new position. So 2 are these positions added, and then 3 is these 2 positions added right here, and then, as you can guess here, would be these 2 positions added. So we'd have 5 different ways of getting there from there. So that's the algorithm. It's not as intuitive as it seems, but yeah, this is one of the common dynamic programming problems. So let's go ahead and go into the solution. Actually, before that, let's go into the time and space complexity. So the time is going to be, I believe it's going to be big O of n plus 1, which just goes out to being big O of n, because we had to loop n times space. Well, for space, we kind of have to think about what are we going to need to perform these calculations. You could store an array of size n plus 1 and, generate these values in there. Or if you didn't want to use that extra space, you could just use like 3 pointers. You could use this could be like a right pointer, this could be a left pointer, and then this could be like the next pointer. And basically the next pointer is always going to be the pointers before it added together. And then we're just going to continuously go along the way. Okay, so because we're going to go through this route of just using pointers. Even though we're using 3 variables, that doesn't mean that we're necessarily using like n space. These variables are going to stay constant. Their size is going to be constant no matter the size of our input. So they're not going to scale as our input grows. Okay, so that means that this is going to be constant space. Okay, so let's go ahead and go into the LeetCode solution over here. All right, so let's get into the coding solution. So, let's shift this over so we can see this fully. Okay, so as I said here, basically if n is less than or equal to 3, then we're just going to return n itself, right? And we know that because if n is equal to 1, right, if this is just one step that you have to climb, well, you can only get to it one way by just taking one step. If you take 2 steps, or if you take one giant step, you're going to land at 2, and then you're going to overshoot it. So you have when n is equal to 1, your output is going to be equal to 1. Then we're also given our prompt. We know that if n is equal to 2, then we're going to output 2. Then also, because of our prompt, given n is equal to 3, we're also going to just return 3, or n itself. So, almost like our base case, but we're not doing any recursion, but you can think of it that way, I guess. So if n is less than or equal to 3, then what we're going to do is just return n, right? Okay, and then we know that it's not the case for 4, because for 4, when n is equal to 4, we have 5 different ways of getting there. Okay, so what we're going to do is we're going to initialize left is equal to 1, right is equal to 1, right? Just like in our pictures here, left and right are going to start at 1. And then what we're going to do is we're going to do a for loop. We're going to do for I in range, just like a normal for loop. And we're going to give it, if you're not familiar with the range function, there's different ways of messing with it, but if you give it 2 parameters, it's going to be the start and stop values. So we're going to give it, we want it to start at, well, let's start with what we want it to stop at. So we're going to do, what do we actually want it to stop at, right? I don't think we've discussed that. So when n is equal to 4, we're going to generate, how many values did we generate? We generated 5 values, or n plus 1 values. So we're always going to generate n plus 1 value. So we want this loop to run for n plus 1, right? Because given 4, we had to generate 5 values, basically. Or we had to run through this step 5 times to get this output here. Okay, and then what are we going to start at? This is a little tricky, considering what I just said. We want it to go end at n plus 1. But if you think about it, because we're assigning left and right already to 1, then technically we've already calculated these values. So we're not really starting here. We're starting like here. We're starting at this position here where I'm putting this red arrow, if you can see this. So I'm going to circle it actually. We're going to start here. We're not starting at this position, because we're already declaring left and right is equal to 1. We're going to start at this position. So realistically, we want to start at 2. And you know, like in it's a common thing in computer science, you start counting from 0. So basically, this is the 0th position, the 1th position, and this is the 2nd position. So that's why we're using 2. And we're using 2 because this is the first value that we're actually going to, calculate by adding left and right. So I hope that explains the start and stop conditions. It can be a little confusing, but yeah, that's what we're going to do. And then let me tab over. So what we're going to do is we're going to calculate our next value is equal to left plus right, right? So we're just going to do left plus right. And then to get our 2, and then what we're going to do is we want to shift our left and right pointers, right? But we want to do, which one do we want to do first? Well, if we shift the left pointer over to 2, then we've lost access to this 1, right? This 1 is gone, basically. So what we need to do is we need to shift right over first, and then we can shift left over. So we can say right is equal to left, and then we can say is left is equal to next value. So I hope that makes sense. Basically, we're moving left over here, or right over to left's value. So right is going to be 1. And then once we've done that first, the order matters. Then once we've done that first, we can just move left over to what we just calculated, which is our next value. Okay, and then this is going to run all the way up to n plus 1. So we're going to calculate our fifth value here. And then when we're done, we can just return next value. Okay, yeah, so let's go ahead and run this, see if I made any mistakes. yeah, so that's that. Like I said before, this is I believe it's big O of n plus 1, which just comes out to being big O of n because you just get rid of constants. Um, I believe so. I believe that's how that works, right? It either might be big O of n plus 1, but I think I think we just get rid of the plus 1. And then the space is constant because we're just using constant variables. This isn't growing as our input size grows. Yeah, thank you for watching.